Year 3, Maths Lesson 12, Objective to Order Fractions. To warm our maths brains up, let's have a go at these 4 questions. Pause the video and then we'll go over the answers. Question number 1. We can see the image for 4/8 is the same as 1/2. 32 sweets shared by 8 gives us 4. Times 3 equals 12. If we take this away from 32, Tilly has 20 sweets left. The pattern continues with 9/10, and 3 times 9 is 27. From the last lesson, where we were comparing fractions, we made some stem sentences. When the denominators are the same, the greater the numerator, the greater the fraction. Or when the denominators are the same, the smaller the numerator, the smaller the fraction. Therefore, 5/7 was greater than 2/7. So let's have a go at putting these fractions in order from smallest to greatest. I've used some circles to model the fractions. Pause the video and have a go. So here is the order of the fractions from smallest to greatest. I use the stem sentence, when denominators are the same, the greater the numerator, the greater the fraction. I could do this without drawing the circles. I just look at the numerator and put them in order. So pause the video here on question number 1 and have a go. Let's check your answers here. Did you notice that the fractions shaded went up in order? They got bigger. For the stem sentence, we should have, when fractions have the same denominator, the greater the numerator, the greater the fraction. Pause the video on questions number 2. Remember the stem sentence about the denominator being the same? Look at the numerator and put them in order, smallest to greatest. Let's check your answers. Were you correct? 1/9, 2/9, 4/9, 7/9, 8/9. Ordering from smallest to greatest. So looking at these two fractions to compare, we can see 1/2 and 1/3 are unit fractions. The numerator is 1, but the denominators are different. 4/9 and 4/5 are non-unit fractions. Again, the numerator is the same, but the denominator is different. Pause the video and read the stem sentences. So using those stem sentences, can we put these fractions in order from greatest to smallest? I've drawn some bar models to help. Notice the bar models are all the same size, but cut into different parts. Pause the video and put them into the correct order, greatest to smallest. So here's the stem sentence. When the numerators are the same, the greater the denominator, the smaller the fraction. So here we have the answers from greatest to smallest. 3/4, 3/5, 3/6, and 3/9. So let's have a go at question number 3. Pause the video while you work out the answers. The answers to question number 3. We can see that when you shade in the fractions are getting smaller. The stem sentence reads, when fractions have the same numerator, the greater the denominator, the smaller the fraction. Pause the video for question number 4. Remember the stem sentence, and this will help you to work out this answer. Remember, we're working greatest to smallest. So here's the answer to question number 4. Did you remember that when the numerator is the same, the smaller the denominator, the greater the fraction? So let's have a look at these set of fractions. Let's put the fractions in order, starting with the greatest. Oh, but what do you notice? The numerators are different and the denominators are different. What do you think we should do to try and work out this answer? I think we should draw some bar models. So here are my bar models. Notice how all the bar models are exactly the same size, but they are cut differently. Seems a little tricky still though. I know I'm going to put the bar models on top of each other so I can compare. So now we can compare the fractions and find the greatest to the smallest. So here we can see that 6/7 was the greatest, followed by 3/4, 4/9 and 2/5. So let's have a go at this next question, putting the fractions in order, starting with the smallest. I can see that the numerators are different and the denominators are different. Perhaps I could use bar models. Or maybe I could use equivalent fractions. Pause the video and have a go. So you may have drawn bar models and compared and then put them in order. Or you may have chosen to do equivalent fractions. Here we have used twelfths. 2/3 is the same as 8/12. 5/6 is the same as 10/12. 3/4 is the same as 9/12. And 7/12 is obviously 7/12. Now you can put them into order from the smallest. So we can see here that the order of the fractions from smallest to greatest was 7/12, 2/3, 3/4 and 5/6. So now let's look at this question, putting the fractions in order from smallest to greatest. Let's think about all the strategies that we have used. But also try to think about comparing the fractions to a half. Pause the video while you have a go. So let's compare them to halves. 4/8 would be half, therefore 5/8 is greater than a half. Well, 3/9 is definitely less than a half. 3/6 would be half, so 5/6 is greater than a half. And 6/7, well, that's greater than a half too. So we can see which one is the smallest here. That's correct. So 3/9 is the smallest fraction. Now let's use the stem sentence. The numerators are the same. The smaller the denominator, the greater the fraction. Can you spot where the numerators are the same? Yes, that's 5/8 and 5/6. So if we look at the denominator, the greater the denominator, the smaller the fraction. So our next number is 5/8. So let's compare 5/6 and 6/7. I've drawn a bar model to show this, and we can see that each of the models need one part to make a whole. We can compare a 7th and a 6th, and we know that a 7th is less than 1/6. So 6/7 is closer to being a whole, therefore it is greater. Let's put these fractions in order now. And so here we have the fractions in order from the smallest to the greatest. Remember, we did 3/9 by comparing it to a half. We compared 5/8 and 5/6 by looking at the numerators being the same and the denominators different. And then we looked at 5/6 and 6/7 and compared them using bar models. Tommy and Dora are ordering fractions in question 5. Tommy says, I cannot order these fractions because the numerator and denominators are different. And Dora says, I think I can use equivalent fractions to help me. Who do you agree with? Take a look at the denominators and see if you can find an equivalent fraction. Pause the video here while you have a go. So did you agree with Dora? I hope so, because we've looked at fractions where the denominators or the numerators were different. So yes, she's right. We changed these into equivalent fractions. 1/5 would become 3/15. 4/15 would stay the same. 2/3 will become 10/15 and 7/15, and then we could order them in size. So for question 6, it's split into 2 parts. A, we are completing the equivalent fractions. Remember, what you do to the numerator, you must do to the denominator. In B, we're ordering the fractions starting with the greatest. Remember to use all the strategies you've learnt. Comparing them to a half, looking at the ones with the same numerator, or looking at the ones with the same denominator. Pause the video. So how did you do? Question 6a. Well, 3/5 is 6/10. 2/9 is 6/27, and 1/7 is 6/42. To order the fractions with the greatest, we start with 6/9, 3/5, 2/9, and 1/7. So for our final question, number 7, Dexter and Alex are ordering fractions from the smallest to the greatest. We're just going to use Dexter's method today, and he's going to make all the numerators the same. Can you use Dexter's method to put the fractions in order? Let's look at the numerators. What number could we make them all? Yes, let's make them all 4. Pause the video. So how did you get on changing all the numerators into 4? Well, 1/7 is 4/28, 2/21 is 4/42, 4/35 stay the same, and 2/7 is 4/14. Now we can compare them. The smallest is 2/21. Next is 4/35. Then we have 1/7, and finally 2/7. Well done. You've done amazing today. Ordering fractions can be very tricky. Remember to email me your work and I can give you some dojos. Stay at home and stay alert. See you soon.